Hello and welcome. In this video, we are asked to solve for the voltage drops across each of our resistors, and this is a series parallel example again. And so we are given the 9-volt source, 9.1 kilo ohms for our R1 value, 10.2 for the R2 in kilo ohms also, 6.6 for the R3 in kilo ohms, and 11.2 kilo ohms for R4. And so to find the voltage drops across each one, we want to figure out which one is a series resistor and which one is a parallel resistor. So we'll go for our total resistance, RT, and we can even use our voltage divider equation to figure this one out. So we want to go for our half RT on bottom divided by on top what we want. And so in this case, we'll go for R1 first. And we'll say that this is going to give us VR1 if we multiply this ratio here by our voltage source. So we can solve for each one of these after we set up our initial equation here. So we're going to go after our RT first. That's our first stage. So we see from our voltage source, our positive lead, we travel up through R1. We have no choice but to go through R1, so it's going to be in series. So we'll say R1 plus. After that, we hit a node down here, and it branches off into two directions. And so we'll say that that's R2 in parallel with R3. We want to make sure we do that first. So we'll wrap that in an extra parenthesis. And then as we continue down here, they combine back together. And so we know now we have a single current again, and that single current is going to go straight through R4 with no choice back up to our negative terminal. So R4 is in series, so plus R4. We can solve for that out and place that on the bottom of our total resistance equation, bottom of our voltage divider equation there. Plug that in. So we know that our total resistance is going to be that 9.1 plus the combination parallel here of 1 over 1 over 10.2, it's in kilo ohms still, plus 6.6, plus 1 over 6.6. We'll close that off and we'll add our final series resistor there of 11.2. So now we're given 24.3 kilo ohms as our total resistance. We'll send that out and we'll plug into our voltage divider equation. We want to put R1 on top, so that's 9.1 divided by the answer we just got for our total resistance. Those two are both in kilo ohms, so they'll cancel each other out. And then we'll multiply by our voltage source value of 9 volts. So now we know that the R1 resistor is going to get 3.37 volts. So moving on from there, we now know that we can solve for our R4. That's the other series resistor combination. We know voltage divider equations go for series combinations. So instead of having R1 on top, we're going to put R4 on top. We'll say 11.2. That's our other series resistor. So we'll say that this one is 4.15 volts. And now we have just the parallel left. We have this combination of R2 and R3 together. And we know that since they are shared in a parallel combination here, that the voltage will stay the same down each branch. The current will be different because they have different resistances, but the voltage will be shared down each branch. So we can treat that as if it's a series resistor. We can apply KVL. That says that whatever we know we lost from either of our series components, whatever's left over is going to be dropped across these parallel components here. So we can take our 9 volts and subtract out what we know we lost across R1, 3.37, and subtract out what we know we lost across R4, 4.15, and we'll be left with 1.48. So the voltage drop across R2 is 1.48 volts. And the voltage drop across R3 is 1.48 volts, right? The currents are different for both of those, but the voltage drops will remain the same. All right, let us know if you have any questions.